Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Sridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subject. Today in our class 12th physics playlist in electromagnetism chapter, we'll study cyclotron and understand construction, working principle, applications and limitation of cyclotron, where a small radio frequency alternating voltage source again and again accelerate a charged particle performing circular motion in normal magnetic field, and ultimately particle achieve millions of EV energy to perform nuclear activities. And this is a very probable board examination question. So let's understand cyclotron. This cyclotron is a huge size electromagnetic device developed by scientist Lorentz in the year 1934. These cyclotrons are used to accelerate positive charged elementary particles like proton, neutron and alpha to tens of million EV energy values. Such high energetic elementary particles are used in scattering experiment of nuclear physics, and these particles, when bombarded on heavy nuclei, can even penetrate inside nucleus and perform desirable nuclear reactions. So in nuclear research and development, cyclotron are very useful device which works as particle accelerator. The principle of cyclotron working is very simple. The large energy can be given to a charged particle with small alternating radio frequency potential source. If that particle pass through electric field again and again and get accelerated by small potential difference each time, and total accumulated energy finally become considerable to do the desired operation. When a charged particle passes through a strong normal magnetic field, it performs a circular motion, and the radius of circular motion depends upon particle velocity or kinetic energy, but its time period doesn't depend upon velocity or kinetic energy. So matching of frequency of circular motion of charged particle and radio frequency alternating voltage source can provide accelerating potential difference energy in small packets again and again several times, and finally total accumulated energy may become millions of EV to perform nuclear scattering experiments. Before explanation of working of cyclotron, first understand construction of cyclotron. Cyclotron consists of two D-shaped hollow metallic semicircular chambers having vacuum called as D1 and D2 here. These chambers act as a Faraday cage and won't allow penetration of electric field produced between two Ds here in this space inside the box. Now these two Ds are fixed horizontally with a small gap, and in that gap a high radio frequency alternating source produce considerable potential difference and alternating accelerating potential to impart energy to charged particle by the work done of electric field. Now two very powerful strong electromagnet made of superconductive conductor material are used to produce a strong and uniform magnetic field normal to the horizontal plane of these two Ds, and in that strong uniform magnetic field, when a charged particle travel with 90-degree velocity angle with magnetic field, particle perform a circular motion. The radius of that circular motion depends upon velocity or energy of particle, but the time period of circular motion doesn't depend upon particle velocity, radius or energy. And we match frequency of circular motion of charged particle with frequency of accelerating radio frequency alternating source and impart energy in small pulses by electric field acceleration to particle, and finally total accumulated energy become good enough and produce accelerated particle of tremendous energy to perform nuclear scattering experiments. The working of cyclotron starts when a particle source produce a positive ion of charge Q and mass m in the space in between two metallic D-shaped chamber as highlighted yellow here, and a radio frequency alternating source will make instantaneously metallic D chamber D1 positive and D2 chamber negative to produce a electric field from high potential to low potential in this air gap. Potential difference of the radio frequency alternating source produce an electric field as shown in this arrow direction, and in this electric field charged particle will get accelerated in the direction of arrow from D1 to d2, and if potential difference produced by AC source is delta V, then on q charge of particle, amount of work done by potential difference become gain in kinetic energy of charged particle produced by particle source, and with that velocity particle enters horizontally in vacuumed metallic chamber D2, over which a uniform normal magnetic field act as shown by crosshair normal to plane and inward. This strong uniform magnetic field is produced by powerful superconductor magnet coils carrying very high current. Charged positive particle accelerated by electric field accelerating potential of radio frequency AC source in this inter D vacuum space enters into hollow D-shaped metallic cage D2, where due to metallic shielding no electric field exists, but powerful superconductive electromagnet produce a strong uniform vertical magnetic field as shown by crosshair over this D plane, and particle velocity vector and magnetic field flux density vector got a 90-degree angle. So this accelerated particle in normal magnetic field experience a magnetic force QVB, and direction of magnetic force is given by Fleming's left hand rule, and for that thumb, forefinger and middle finger of left hand are stretched mutually perpendicular, and forefinger is directed in the direction of magnetic field normal to D plane inward as shown by cross and this forefinger direction, and this middle finger indicate the direction of positive charge motion, then this thumb indicate inward force on this charge particle, and particle when perform a curved circular motion, centripetal QVB force get balanced by centrifugal mv square by r force, and the radius of this circular path is given as mv over qb, where m and q are respectively mass and charge of accelerated particle, v is its velocity, and b is existing uniform normal magnetic field flux density. Now in place of moment mv, we can also write energy as moment is equal to root of 2me, and according to energy of particle perform a semicircle path in metal case D2. The time period and frequency of circular motion in magnetic field doesn't depend upon particle velocity or kinetic energy, and it is given as ratio of 2 pi m to qb, or frequency is given as qb upon 2 pi m, and with this time period or frequency and this radius, particle perform a semicircle and cross this inter D space once again. Time to complete this semicircle part of circular motion is half of time period. Time period is 2 pi m over qb, and half time is 2 pi m over 2 qb or pi m over qb. And we match the frequency of this radio frequency alternating source with frequency or time period of circular motion, and exactly in this time period this alternating radio frequency AC voltage source change its polarity, and now metal case D2 become positive and D1 become negative, and the direction of electric field in this inter D vacuum space change its direction, and in this electric field the potential difference of alternating source accelerate particle once again from metal case D2 to D1 in this electric field, and the gain in kinetic energy is work done on q charge by potential difference of electric field between two D's, D2 and D1 delta V, and this work done get converted into gain in kinetic energy, and the particle kinetic energy will increase, and with increase of energy and velocity particle once again comes in another metallic case D1, where due to electrostatic shielding of Faraday case no electric field exists and only a perpendicular normal magnetic field exists, and that magnetic field produce magnetic force on moving charge, and as velocity of particle and magnetic field got 90-degree angle once again, so the path of moving charge particle again become a circle but of higher radius, higher velocity and higher kinetic energy. After acceleration in metallic D1 charge particle with higher velocity and higher kinetic energy describe a circular path of greater radius in this normal uniform strong magnetic field, and after a pre-specified time, as time period and frequency doesn't depend upon velocity or kinetic energy of particle, the same mass and charge and same magnetic field will produce same time interval to cover half circle, and in the same time interval the alternating radio frequency source which produce electric field in between two D's in this vacuum gap also alter its polarity, and as particle perform semicircle and cross metal case D1 comes in electric field of radio frequency AC source and once again get accelerated from metal case D1 to D2 in this air gap by accelerating potential difference. So each time when particle cross inter the gap space, the polarity of radio frequency alternating potential source alter, and each time accelerate moving charge particle in steps again and again, and particle perform circular motion in these two metallic D in only influence of normal magnetic field with increased velocity, increased kinetic energy and increased radius, but the time period of semicircle movement remains the same and matches with frequency of radio frequency source, and finally particle acquire greater and greater maximum velocity and energy and describe circular orbit of highest radius, and in the end it come out of magnetic influence and go straight with tremendous energy and can strike target heavy nuclei, and either particle scattering or some radioactivity action may take place as desired by this action of particle accelerator. Now particle will have maximum kinetic energy or velocity when it describe path of largest radius, and let the largest radius is capital R, then maximum velocity have a relation with largest radius mv upon qv, or in place of maximum velocity we can also write maximum energy as mv is equal to root of 2me, and relation of radius and maximum energy can be simplified as expression of maximum energy of accelerated charge particle, and it become q square b square r square upon 2m, and with this maximum energy particle in the absence of field effect go straight and hit the target as desired from particle accelerator action. In our examination, limitation of cyclotron is often asked. Though cyclotron is the best particle accelerator practically used in nuclear research and high energy particle studies, but it also got some limitations. It cannot accelerate neutral particles like neutron or neutral atoms. It can only accelerate charged particle, but both positive and negative charged particle can be accelerated by cyclotron. Now it cannot accelerate electron, as electron having highest charge to mass ratio got very high frequency of circular motion in magnetic field due to high value of charge to mass ratio, and such high frequency radio frequency source of stable nature are rarely available, so technically it is very difficult and unmanageable to accelerate electron in cyclotron. And when we accelerate even heavy charged particle to a very high energy state, the accelerated velocity of charged particle become comparable to speed of light, and in that case due to relativistic correction the dynamic mass of moving particle become different from rest mass of particle, as velocity of particle approaches very close to speed of light, and due to this relativistic correction in mass the frequency of circular motion won't remain stable, and for such uncertain, unpredictable, variable frequency conditions, matching of frequency of alternating radio frequency source and particle frequency of circular motion become very difficult, and we cannot accelerate particle to a limitless high speed. There are certainly a maximum speed limit at which such cyclotron can work. The practice of these two numerical examples will enhance our subject understanding, clear all our doubts, and make our study exam centric. So let's practice these two numerical examples. A cyclotron is used to accelerate protons. What should be the operating magnetic field flux density that operates normal to D plane if radio frequency oscillator frequency is 10 megahertz, which is connected between two Ds. We have to also calculate the maximum kinetic energy of proton beam produced by accelerator if the radius of D is 60 centimeter. So it is given that frequency of oscillator 10 megahertz must be the frequency of circular motion of proton in D section, and we know the frequency of circular motion for a particle of mass m and charge q is given as 2 pi m over qb. So from this relation, as frequency of circular motion and frequency of oscillator must match, we know frequency of circular motion, so the magnetic field flux density is 2 pi m frequency divided by q, and calculation results as 2 pi. Mass of proton is 1.67 into 10 to the power 27 kg, and the frequency 10 megahertz in hertz become 10 to the power 7 hertz, and the charge of proton is 1.6 into 10 to the power minus 19 coulomb. And when this numerical values are solved, it is found that the magnetic field flux density that works normal to D plane is 0.65 Tesla. In circular motion, the radius of circular path got a relation mv upon qb, and for maximum velocity, particle should describe path of maximum radius equal to radius of d 60 centimeter or 0.6 meter, and when we convert moment into energy as moment mv is equal to root 2 me, the relation of energy will become q square b square r square upon 2m, and for proton charge is 1.6 into 10 to the power minus 19, and it is squared for q square relation. Working magnetic field in this case for 10 megahertz frequency of circular motion is 0.65 Tesla, that again squared, and the radius of cyclotron d is 0.6 meter, that also gets squared. So q square b square r square divided by 2 times mass of proton 1.6 into 10 to the power minus 27, and this mathematical expression gives kinetic energy in joule, and to convert that joule energy into EV, we should divide it by electronic charge, and when this expression is divided by electron charge, we will get energy in EV, and this comes as 7.28 into 10 to the power 6 EV or 7.28 MeVs. And such cyclotron can accelerate proton up to 80 MeVs energy level if the radius of D is higher or working magnetic field is stronger. In two different cyclotrons, an alpha particle and a proton are released from the center of cyclotrons and made to accelerate. The question is, can both be accelerated at same cyclotron frequency? Then answer is, the two particles won't have same charge to mass ratio, so they can't be accelerated by same cyclotron frequency, as frequency of circular motion is given as qb upon 2 pi m, and for same magnetic field flux density, the frequency is proportional to ratio of charge to mass, and for proton charge to mass ratio is E by m, and for alpha particle having 2 times electronic charge and 4 times protonic mass, the ratio of charge to mass become half of proton. So the frequency to accelerate alpha particle with same magnetic field flux density is only half of frequency of proton. So it need two different settings to accelerate proton and alpha particles. The same magnetic field and same frequency won't work to accelerate both particles together. If in one cyclotron with two different frequencies, once alpha particle and another time proton are accelerated, then which of the two particles will have higher velocities at the exit of highest radius d position? So the radius of circular motion is given as mv upon qb, where m and q are mass and charge of accelerated particle, v is velocity of particle, and b is working magnetic field. And from this expression, the velocity of accelerated charge particle is given as qb r over m, where b is normal uniform working magnetic field of cyclotron, r is radius of cyclotron d, and for same amount of working magnetic field and same radius of d section, the velocity is proportional to charge to mass ratio, and q by m of proton is 2 times of alpha. So proton will have twice velocity than alpha if accelerated with same magnetic field in the same cyclotron. In last 20 minutes, we have solved one most probable board examination question, and we have explained both construction and working of cyclotron. We have also described application and most often asked limitation of cyclotron, and the numerical problem are also very useful for exam preparations. Like this, you will find our other learning video equally useful in exam preparation, and you can use them in your studies and share them with your friends. And if you like our online doubt clearing classes or dedicated exam centric notes, do join membership of our YouTube channel Shridevi Classes just by clicking join button beneath. Happy learning, have a nice time. Thank you very much.